morning students. Last class we have discussed about dimensional formula for various physical quantities like velocity. The dimensional formula is Lt minus 1. Acceleration, the dimensional formula is Lt minus 2. And for universal gravitation constant, dimension is m minus 1 L cube p minus 2 and so on. Then we discussed about principle of homogeneity of dimensions. Today we are going to discuss about applications of physical dimensional quantities or dimensional analysis. So there are three applications of dimensional analysis. One, convert a physical quantity from one system of unit to another system. Then check the dimensional correctness of a given physical equations. Establish relations among various physical quantities. Now we will discuss about convert a physical quantity from one system of units to another. Now, system of units. We have already discussed about system of units. There are three system of units: CGS, FBS, MKS. So there are three system of units we have discussed already. Now here, for example, I want to convert CGS into MKS. We can use this system of units. Okay. Now how to convert one system of unit to another system of unit? So by using dimensional formula, we can convert a physical quantity from one system of units to another. This is based on the fact of this application is based on the fact of product of numerical value and its unit. The product of numerical value and its unit is equal to constant. Now we will see an example. Gravitation constant G is equal to 6.67 into 10 power minus 11 Newton meter square kilogram minus 2. Here you see, this is what numerical value. This one is unit. This will be constant. Understood? Compared to this, I think understood. Now, this application is based on two facts. One, equate one system of unit to another system of unit. Equate one system of unit into another. That is N1 U1 is equal to N2 U2. Next one is dimensional formula. Dimensional formula, that is N1 M1 power A, L1 power B, P1 power C is equal to N2 M2 power A, L2 power B, P2 power C. Write the dimensional formula. First, we must equate one system of unit to another system. Then you must write the dimensional formula. This A, B, and C are the powers of dimensions M, L, T. Understood? It is clear now. Now we will see an example. Convert 76 cm of mercury pressure into Newton per meter square using the method of dimensions. So what is given? Height 76 centimeter. So height is given. So this centimeter is in CGS system. This Newton per meter square is in MKS system. So now we should convert this CGS into MKS. So we should convert pressure. Pressure should be converted from CGS into MKS system. Now we will write M1, L1, T1 in CGS system like that. M2, L2, T2. So C means centimeter. So 1 centimeter. G gram. So 1 gram. S again. So 1 second. Like that. M meter. 1 meter. A kilogram. 1 kilogram. S again. 1 second. Now in CGS system, what is pressure? Let it be T1. Like that, in MK system, T2 that he has to calculate. T2 we are going to calculate. Now we will calculate T1. We know that formula for pressure is X rho G. Height, density, and this one is acceleration due to gravity. So let it be T1. What is height is given? 76. Density is 13.6 and gravity is 989 centimeter minus 2. So this will be value for T1. So T1 I will write this as 76 into 13.6 into 989 centimeter minus 2. Now I want to convert T2. What are the two steps? 1. Equate one system of unit to another system of unit. That is N1. This is a general formula. This is the general formula. Now N1 is nothing but what? Numerical value. So pressure. So P1, M1A, L1B, P1C is equal to P2 now I want to calculate the value of T2. So T2 is equal to, bring this side, so P1 now you group all things, mass, length and time. So I can write T2 is equal to P1 into M1 M2 whole power A, L1 by L2 whole power B, T1 by T2 whole power C. Let us consider this is equation number 1. So now I want to find out the powers by using dimensional formula. This is the second step. Here the first step is equating the one system of units to another system of units. Now we are going for second step, that is we must write the dimensional formula for pressure. So dimensional formula for pressure is M L minus 1 P minus 2. This is the dimensional formula for pressure. Here M power 1. Now we compare this mass. From this I can get the value of A. B as well as C. So A is equal to 1. B is equal to -1. C is equal to -2. Substitute these values as well as P1 value in equation number 1. So P2 is equal to P1 value. What is P1 value? 76 into 13.6 into 980. Then M1 1 gram by M2 1 kilogram whole power 1. Then L1 1 centimeter, L2 1 meter whole power B value -1. Then P1 once again, P2 once again whole power C value is -2. Now 76 into 13.6 into 980. This gram you convert into kilogram because we need MKS system. So 1 gram, how I can convert? 10 power -3 kilogram divided by 1 kilogram whole power 1. Then 1 centimeter, it is 10 power -2 meter divided by 1 meter whole power -1. Here is 1 second and 1 second cancelled, so 1 power -2. Now you see this kilogram cancelled, meter cancelled. So 76.13.6 into 980, 10 power -3 whole power 1, 10 power -2 whole power -1, 1 power -2. Now 76 into 13.6 into 980 into 10 power -3 into 1 -3 into 10 power -2 into -1 plus 2 into 1 power anything, it is 1. Now this can be written as 76 into 13.6 into 980 into 10 power -3, 10 power 2. -3 plus 2 becomes -1. That is equal to, if I multiply these values, 1 0, I will be getting this 1012,928 into 10 power -1. Here I want to put the decimal here. So this decimal here, I want to put it here. So it becomes what? 1.01. Okay. Into how many digits it moved front? 1, 2, 3, 4, 5, 6. So 10 power 6 into 10 power -1. That is equal to 1.01 into 10 power 5. Here, what is the unit for CGS dyne? MKS means Newton. Centimeter means MKS it is meter. Is clear? So now, example 1.13. If the value of universal gravitational constant in SI is 6.6 into 10 power -11 Newton meter square kilogram -2, then find its value in CGS system. So what is given? Gravitational constant G is given. It is in the form of SI system. That is 6.6 into 10 power -11 Newton meter square kilogram -2. What I asked to find out? This gravitational constant in CGS system. They also calculate in CGS system. Now convert, that is CGS, that is SI system, I can write it as NKS system, that has to be converted into CGS system. So M1, L1, T1, M2, L2, T2. M, what? Meter. K, kilogram, mass. S, second, that is time. Here, C, centimeter, length. G, gram, second, time. So here, G, SI is going to what? 6.6 into 10 power minus 11 Newton meter square kilogram minus 2. Here we asked to find out CGS, gravitational constant in CGS. It's clear now. So what is the first step? What? First step is what? Equate one physical quantity to one physical quantity to other. That is what? N1, M1, L1, T1, that is A, B, C. Now you write it in this form. This N1 is nothing but what? G, SI. So G, SI, M1, L1, T1. And L2 is nothing but G, CGS. Now we have to calculate G, CGS. So G, CGS is equal to G, SI divided by this one. Now we combine this one. So G, SI, M1 by M2 whole power A, L1 by L2 whole power B, T1 by T2 whole power C. That is answer equation number 1. What is the second step? First step, equating. Second step is to find out the dimensional formula. What is the dimensional formula for gravitational constant? G, SI. M minus 1, L, Q, P minus 2. Now, what will be the value of A? A is equal to comparison M, here M. So, power term A minus 1. Then B equal to 3. C minus 2. Now, you substitute A, B, C values as well as G, SI in equation number 1. So, G, CGS is equal to 6.6 into 10 power minus 11. Then M1. What is M1? 1 kilogram divided by M2. 1 gram. Whole power. What is A value? Minus 1. Then L1. 1 meter. L2. 1 centimeter. And B value 3. Then T1 1 second, T2 1 second, whole power C value minus 2. So this is equal to 6.6 into 10 power minus 11. 1 kilogram. Convert this gram into kilogram. That is 10 power minus 3 kilogram. Whole power minus 1. 1 meter by convert the centimeter into meter. So 10 power minus 2 meter whole power 3. The second and second cancel. So 1 whole power minus 2. Here is kilogram cancel, meter cancel. So 6.6 into 10 power minus 11. Bring this 10 power minus 3 to the numerator. It becomes 10 power 3 whole power minus 1. This one 10 power minus 2. It becomes 10 power 2 whole power 3. This one is 1. So 6.6 into 10 power minus 11 into 10 power 3 into minus 1 minus 3. 10 power 2 into 3, 6. That is 6.6 into 10 power minus 11 minus 3. It becomes what? Minus 14. Minus 14 plus 6. It becomes minus 14, 6. So it becomes minus 8. Here. So now what is the meter is a unit in the MKS system. If I want to convert it into CGS, I will be writing it as dyne. Meter means centimeter square. Kilogram means gram. Understood? So next application is to check the dimensional correctness of a given physical equation. There are two steps in this application. Step 1, write a dimensional formula. Write a dimensional formula. Second step, check dimensionally or check dimension of each term in a given equation. In a given equation, check dimension of each term in a given equation. Now we know that equations of motion. There are three equations of motion. One is v equal to u plus at, s is equal to ut plus of at square, v square equal to u square plus 2as. Now let us consider this first equation and we will check dimensionally it is correct or not. So v equal to u plus at. What is the first step? Write a dimensional formula. Velocity dimensional formula is Lt minus 1. This is u initial velocity. So Lt minus 1 plus a acceleration Lt minus 2. This t. So Lt minus 1 is equal to Lt minus 1 plus Lt minus 2 plus 1. It becomes what? Minus 1. Next, we will go for a second step. Check each term. Check each term dimensionally they are same or not. Check dimension of each term. The given equation is same. So check here Lt minus 1, here also Lt minus 1, here also Lt minus 1. So all the terms are what? Dimensionally same. So hence I can write this equation is dimensionally correct. Hence the given equation is dimensionally correct. Next we will go for an example. Check the correctness of the equation of mg square equal to mgx using dimensional analysis method. Now let us consider this equation of mg square is equal to mgh of dimensionless m. For velocity Lt minus 1 whole square. For m it is m. For gravity acceleration that is Lt minus 2. Height it is length L. So here I can write it as m L square. E minus 1 into 2 minus 2 is equal to m L, here 1, it becomes L square E minus 2. So go for the second step. Check each term whether the dimensions are same or not. Check they are same. Hence I can write the given equation. The given equation is dimensionally correct. Understood? So third application today we will discuss, that is to establish the relation among various physical quantities. Now let us consider Q is directly proportional to Q1, Q2, Q3. There A, B and C. Physical quantity, this physical quantity Q, it depends on Q1, Q2 and Q3 physical quantities, where A, B and C are dimension for physical quantities. Now if I remove this proportionality, I am writing it a constant K, Q1, Q2, Q3, that is Q1A, Q2 power B, Q3 power C. Now this A, B, C are powers of dimensions of Q1, Q2 and Q3. There are two steps are involved in this. Step 1, write the dimensional formula. Write the dimensional formula. Second one is equate the powers of equation. Equal the powers of equation. Now, obtain an expression for the time period T of a simple pendulum. The time period T depends upon mass m of the bob, length L of the pendulum, and third, acceleration due to gravity G at the place where the pendulum is suspended. The K value is given as 2 pi, it has been proved experimentally. So, the time period T, it depends on mass m, then length of the pendulum, and then acceleration due to gravity. Then the powers be equal to x, y, z. Acceleration due to gravity G. Now if I remove the proportionality, some constant T, m directly proportional to x, L or y, G power z. So now go for step 1, write the dimensional formula. For time period, dimensional formula is T. For constant, no dimension. For mass, m. For length, L. For acceleration due to gravity, Lt minus 2. Now this one I am writing it in the form of mLt. So m0 L0 T. This is T power 1. Here m, x, L, here y, here z. So y plus z, then T multiply this minus 2z. So we have completed the dimensional formula. Second step, equal the powers. Now if you take m, so x is equal to 0. X is equal to 0. If I take L, y plus z is equal to 0. Y plus z is equal to 0. If I take T, minus 2z equal to 1. Minus 2z is equal to 1. Now we calculate z value. Z is equal to minus 1 by 2. Now substitute the value of z here. Y minus half is equal to 0. So y is equal to 1 by 2. Now we substitute these values, x value, y value and z value in equation number 1. So t is equal to k m x is 0. Then L power y is half. G power is z is minus half. So I can write k, any number power 0, 1, so neglect. L power half, I can write it as square root of L. This g power minus half, I can write it as square root of g. Now this t is equal to a square root of L, square root of g. So I can write it as square root of L by g. So the given value a is equal to 2 pi. Therefore t is equal to 2 pi square root of L by g. T is equal to 2 pi square root of L by g. So example 1.16. The force F acting on a body moving in a circular path depends on mass of the body m, velocity v, and radius r of the circular path. Obtain the expression for the force by dimensional analysis method that K is equal to 1. So, force, it depends on mass of the body, velocity and radius of the circular path. So let it be power A, B and C. If I remove the proportionate, there will be a constant and it is dimensionless constant. A, m power A, v power b, r power c. Now let us consider this is equation number 1. Step 1. First step is what? Write the dimensional formula. For force, mlt minus 2. Dimension for force is mlt minus 2. A, no dimension. For m, mass, m power a. This is velocity, lt minus 1 whole power b, or length. So L power c. So m lt minus 2 equal to m power a, L, bring this b here, L power b, t power minus b, L power c. So m L t power minus 2 equal to m power a, here 1 L, here L. So I can write L d plus c, p power minus b. So second step, equate the powers of dimension. M, take m here means 1, L 1. So if I take m, a is equal to 1. Then if I take L, d plus c is equal to 1. d plus c is equal to 1. Then if I take p, minus b is equal to minus 2. Minus b is equal to minus 2. So therefore b is equal to 2 is minus cancel. Substitute the value of b here. 2 plus c is equal to 1. C is equal to 1 minus 2. Therefore c is equal to minus 1. Now we substitute the value of a, b, c in equation number 1. So f is equal to k m power 1, b power 2, r power minus 1. So f is equal to k m b square r power minus 1, it comes to denominator, so it becomes r. So the given k is equal to, since k is equal to 1, it has been experimentally proved. So therefore f is equal to m b square by r. F is equal to m b square by r. That is Roman number 4. Question number 3. Assuming that the frequency gamma of a vibrating string may depend upon applied force, length, mass per unit length, and prove that gamma is directly proportional to this frequency is directly proportional to 1 by L square root of f by m using dimensional analysis. Now, this frequency it depends on applied force, length, then mass per unit length. Mass per unit length. Now, write A, B, C. Now, if I remove the proportionality, some constant K, F power A, L power B, M power C. Let us consider equation number 1. In this, there are 2 steps. Step 1, first write down the dimensional formula. Frequency reciprocal of time period. So it is e power minus 1. So I can write m0, l0, e power minus 1. For k, no dimension. For force, ml e minus 2. For a, for length, l. And here m, mass per unit length. Mass per unit length. Mass per unit length. So dimension is ml minus 1. So I will write it as ml minus 1 power c. Understood? So m0 l0 e power minus 1 is equal to m power a l power a e power minus 2a here l power b m power c l power minus c. So m0 l0 e power minus 1 m a plus c l a plus b t minus 2a. So l three times there. So l a b minus c and t minus 2a. Now what is the second rule? Equal the powers of dimension. So m a plus c equal to 0. A plus c is equal to 0. Next you take l. A plus b minus c is equal to 0. Then you take t. Minus 2a is equal to minus 1. Minus 2a is equal to minus 1. So a is equal to, this minus minus will be cancelled. So 1 by 2. A is equal to 1 by 2. Substitute here. Plus t equal to 0. So therefore c is equal to minus 1 by 2. C is equal to minus 1 by 2. Now you substitute a value and c value here. So 1 by 2 plus b minus, here minus, so it becomes plus 1 by 2 equal to 0. Half plus of 1. 1 plus b equal to 0. So b equal to minus 1. Now you substitute a, b and c value in equation number 1. So frequency is equal to a, f, a value is 1 by 2, l, b value is minus 1, m, c value is minus half. This I can write it as a square root of square root of f. This one I can write 1 by l. This one I can write 1 by square root of m. So frequency is equal to a. This one I can write it together, square root of f by m into 1 by l. Here k is equal to 1. Therefore, frequency is equal to 1 by L square root of F by M. So, if I want to bring this one, so if I take the proportionality, I can write, or I can write this way. Now, proportionality is okay. A proportionality, that is frequency is proportional to 1 by L square root of F by M. Okay. So next we will see limitations of dimensional analysis. This method gives no information about the dimensionless constant in the formula. For example, if I take kinetic energy is equal of mv square. They are not giving any information about this. So, the dimensionless constant, no information, doesn't give any information about this one. Next one is, this method cannot decide whether the given quantity is a vector or scalar. For example, speed, the dimension is Lt minus 1. If I take velocity, the dimension is Lt minus 1. Here, both the physical quantity having same dimension, but they are, the speed is a scalar quantity, but velocity is a vector quantity. But in dimension, there is no representation about scalar or vector. The third one is, this method is not suitable to derive relations involving trigonometry. For example, x is equal to y cos theta. So there is no fundamental quantity or dimensions for trigonometric one. Then exponential, y equal to e power x. There is no dimension for e power x. Like that logarithmic functions, y is equal to e power x log x. So for this log x, there is no dimension. Next, it cannot be applied to an equation involving more than 3 physical quantities. That is, kinetic energy is equal to half mv square. Then potential energy is equal to mgh. So here we are having two different quantities. Here we are having 3 quantities, physical quantities. So we can apply only up to this. Suppose if you are having y equal to a square b 3 c power 4 by x cube. Here we are having 3 physical quantities. For this, we can't apply dimensional analysis. Next, we can only check on whether a physical relation is dimensionally correct, but not the correctness of the relation. That is, s is equal to ut plus of at square. This is dimensionally correct and the equation is also correct. But if I write s is equal to ut plus 1 by 4 at square, dimensionally this equation will be correct, but actually this equation is wrong. So these are the limitations of dimensional analysis. So we have completed the measurement chapter. Next we will go to unit 2, kinematics. Thank you.